This is SpaceTime Series 24, Episode 5. Coming up on SpaceTime, how the solar wind's been stripping away the Martian atmosphere, giant X-ray bubbles detected in the Milky Way's galactic halo, and the discovery of a new supercluster. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Five years after NASA's MAVEN spacecraft first entered orbit around the red planet, data from the mission has led to the creation of a map of electric current systems in the Martian atmosphere. A report in the journal Nature Astronomy claims these currents played a fundamental role in the atmospheric loss that transformed Mars from a warm, wet world capable of supporting life into an inhospitable, freeze-dried desert. MAVEN, the Mars Atmosphere and Volatile Evolution spacecraft, was developed to investigate the red planet's upper atmosphere and ionosphere to see how the solar wind strips away that atmosphere. The study's lead author, Robin Ramstad from the University of Colorado Boulder, says he's now working on using these currents to determine the precise amount of energy that's drawn from the solar wind to power atmospheric escape. Earth has similar current systems, often seen as the colourful auroral displays in the night skies above the polar regions, known as the aurora borealis and aurora australis, the northern and southern lights. Earth's aurorae are strongly linked to currents generated by the interaction between Earth's magnetic field and the solar wind. These currents flow along magnetic field lines into Earth's atmosphere, concentrating at the poles. But studying the flow of electricity thousands of kilometres above the Earth only tells part of the story about the situation on Mars. See, the difference lies in the two planets' different magnetic fields, because while the Earth's magnetism comes from within the planet, Martian magnetism doesn't. Earth's magnetism comes from its core, where molten electrically conducting iron generates a geodynamo, producing a global magnetic field which surrounds the entire planet. Now, since Mars is a rocky terrestrial world like the Earth, one might assume that it is the same kind of magnetic paradigm functioning there as well. But it doesn't. Mars is a lot smaller, and so it's cooled down a lot quicker than the Earth, meaning its core is basically no longer molten, or if it is, there's not enough there to generate a geodynamo. The best Mars can do today are relatively small patches of magnetized crust. So that means something very different from what's observed on Earth must be happening on the red planet. The solar wind, made up largely of electrically charged electrons and protons, blows constantly from the sun, streaming out at around 1.6 million kilometres an hour. It bathes and interacts with all the objects in our solar system. And because it's ionized, the solar wind's also magnetized, but a magnetic field can't easily penetrate the upper atmosphere of a non-magnetized planet like Mars. Instead, currents that the solar wind induces in the planet's ionosphere cause a pile-up and strengthening of the magnetic field, creating a so-called induced magnetosphere. But exactly how the solar wind powers this induced magnetosphere around Mars hasn't been well understood until now. As the solar wind's positively charged ions and negatively charged electrons smash into the stronger induced magnetic field near Mars, they're forced to flow apart due to their opposite electric charge. Some ions flow in one direction, some electrons in the other, forming electric currents that drape around from the day side to the night side of the planet. At the same time, solar X-rays and ultraviolet radiation constantly ionize some of the upper atmosphere on Mars, turning it into a combination of electrons and electrically charged ions that can conduct electricity. Ramstad says Mars's atmosphere behaves like a sort of giant metal sphere enclosing an electric circuit. The currents flow in the upper atmosphere, with the strongest current layers persisting at around 120 to 200 kilometres above the planet's surface. Both MAVEN and previous missions have localised hints of these current layers before, but they've never been able to actually map the complete circuit from its generation in the solar wind to where the electrical energy is deposited in the upper atmosphere. Directly detecting these currents in space is incredibly difficult. Now, luckily, the currents distort the magnetic fields in the solar wind, and so is detectable by MAVEN's sensitive magnetometer. The authors were able to use MAVEN to map out the average magnetic field structure around Mars in 3 dimensions and calculate the currents directly from the distortions of the magnetic field structure. Without a global magnetic field surrounding Mars, the currents induced in the solar wind can form a direct electrical connection with the Martian upper atmosphere. The currents transform the energy of the solar wind into magnetic and electric fields that accelerate charged atmospheric particles into space, thereby driving atmospheric escape. Solar wind-driven loss of the Martian atmosphere has been active for billions of years, contributing to the transformation of the red planet from a warm, wet world that could have once supported life to the global freeze-dried desert it is today. This report from NASA TV.
MAVEN is a spacecraft that's orbiting Mars. It's been there since 2014. MAVEN, in this case, is an acronym. It stands for Mars, Atmosphere, and Volatile Evolution. And this gives a clue as to what MAVEN's real goal is. It's to study the top of the atmosphere and how the gases in the top of the atmosphere might escape from Mars away to space.
So the atmosphere of Mars must have been a lot thicker about 4 billion years ago, and today it's very cold and dry. And MAVEN is meant to understand the atmosphere as it is today and how it has evolved into this current cold, dry state.
One of the things we're trying to understand with MAVEN is whether a magnetic field for a planet is important for regulating the climate or allowing the planet to keep an atmosphere. Earth has a global dynamo magnetic field. Mars does not, but Mars has an induced magnetosphere. It has an induced magnetic field.
The upper atmosphere of Mars is being ionized by solar radiation, and so the electrons are being stripped from the atoms in the atmosphere. When that happens, it turns into what we call a state of plasma. This plasma in the upper atmosphere is very conductive. It leads electric currents to flow through it. Electric currents, they shape the magnetic fields that are around them, and that's actually how we see them with MAVEN. We take magnetic field data and we map it around the planet, and from that, the currents emerge. We've known how the currents flow in the Earth's magnetosphere for decades, but we don't know how that works around Mars. We don't know how it influences the interaction with the solar wind, because it determines how energy is flowing into the atmosphere, how it's transferred from the solar wind into the system, and that's what we're trying to do with MAVEN. When you just look at the data as it comes down, you're just seeing a little squiggly line, essentially. You're seeing the magnetic field strength and its direction vary as the spacecraft is flying through different regions. And so what you have to do is you have to actually map it to the planet and to this interaction with the solar wind. And then it starts to emerge that you have a drape situation where the magnetic field of the solar wind encounters the planet and it starts to wrap around it. And the reason it wraps around the planet is those electric currents that we are seeing.
The magnetic field in the solar wind is straight lines. You can think of straight spaghetti noodles, and it's flowing towards the planet, and those spaghetti noodles wrap around this basketball-shaped planet. And that's indeed what we saw in the data, the magnetic field lines draping around Mars as a planet. One thing that wasn't so expected was the specific configuration of the electric currents that we derive from the magnetic field data. If Mars is a ball here, it's sort of this cup shape on the day side that loops back on itself. What wasn't so intuitive to me was the directions of those currents and the fact that it wraps continuously around to the night side, and it makes this marvelously complex current system on the night side as well.
This is the first time that we've been able to actually map out the currents, so we can see where the energy is being transferred. We can see what actually forms the underlying mechanisms creating these induced magnetospheres that are not just common here in the solar system. They're 50% of the planets that have them, of the terrestrial planets. And if you want to understand how the atmosphere of Mars and Venus, why they're so different from the Earth and why they're so different from each other despite both being non-magnetized, we need to understand their induced magnetospheres first.
So knowing how these global current systems are configured teaches us about how charged particles near the planet are going to move, both charged particles in the solar wind and charged particles from the atmosphere itself that are in the process of escaping to space. So now we can understand better where those particles came from, how they move near Mars, and where they're going to go next. That in turn teaches us about atmospheric escape from the planet and the history of the atmosphere over time. How thick has it been? How much has been removed?
And in that report from NASA TV, we heard from MAVEN co-investigator David Brain, as well as the study's lead author Robin Ramstad. This is SpaceTime. Still to come. Giant X-ray bubbles detected in the galactic halo, and a new supercluster discovered by astronomers. All that and more coming up on SpaceTime. astronomers have discovered giant X-ray bubbles extending thousands of light years above and below the central region of the Milky Way. This region, located some 27,000 light-years away, is home to Sagittarius A star, the galaxy's central supermassive black hole, which contains some 4.3 million times the mass of our Sun. The newly discovered giant X-ray bubbles extend some 45,662 light-years above and below the galactic center. They were discovered by astronomers using the German Rosetta X-ray telescope aboard the Russian Spectre RG spacecraft, which is located in the Lagrangian L2 position on the opposite side of the Earth to the Sun. Launched in July 2019, Rosetta has undertaken a complete all-sky survey, detecting over 1 million X-ray sources, more than doubling the number of X-ray sources previously known. As scientists have been sifting through the data, they came across an astonishing new feature. A huge circular structure forming what looked like part of a giant X-ray bubble emerging from below the galactic center. Now, as we reported previously on SpaceTime, a similar structure had already been detected stretching out above the galactic center. And combined, these two X-ray bubbles are akin to the Fermi gamma-ray bubbles discovered in 2010. A report in the journal Nature suggests the sharp boundary seen in these bubbles appears to trace shock fronts, disturbances in a hot gas envelope around the Milky Way caused by either a burst of star formation or by an outburst from Sagittarius A star itself. The authors have calculated that the energy needed to produce such impressive structures would be equivalent to the energy released from no less than 100,000 supernovae. This is SpaceTime. Still to come. A new supercluster discovered by astronomers, and Griffith University to develop a new satellite with Gilmour Space. All that and more still to come on SpaceTime. Another data release by Rosetta has allowed astronomers to discover a new supercluster consisting of a chain of 8 galaxy clusters. Superclusters are the largest known structures in the universe. They're made out of chains of galaxy clusters, and each cluster can consist of thousands of galaxies. The new observations, reported on the pre-press physics website archive.org, are part of the Space Telescope's EFEDS, or Final Equatorial Depth Survey. They show a range of structures, from dense, high-mass galaxy clusters through to low-density filaments and sheets of stars, gas and dust. The supercluster was located at a redshift of 0.36. That's about 4.96 billion light-years away. Optical and X-ray data showed that the northernmost clusters in the group are going through a massive off-axis merger, with both a double merger and a pre-merger underway. The largest and most massive galaxy cluster, located in the northern part of the supercluster, contains some 580 trillion solar masses, while the least massive galaxy clusters in the group have around 130 trillion solar masses each, with other clusters containing between 140 and 250 trillion solar masses. The idea of a major merger taking place is supported by data showing 2 radio relics in the north and southeast of the northernmost cluster, together with an elongated radio halo and galaxy density contour map showing 2 peaks in the northern and southern regions of the cluster system. This is SpaceTime. Still to come. Griffith University to develop a new satellite in collaboration with Gilmour Space. And later in the science report, the American Food and Drug Administration has rejected British plans to delay giving a second dose of the COVID-19 vaccine. All that and more coming up on SpaceTime. Gold Coast aerospace company Gilmour Space has signed a Memorandum of Understanding with Griffith University to develop satellites for launch into low Earth orbit by 2023. The partnership will include research and development on lightweight alloy materials and new manufacturing methods, as well as advanced sensors and imaging technologies, new generation onboard satellite IT systems including the integration of artificial intelligence, and new telecommunication systems. As part of the project, a 100 kilogram prototype Earth observation spacecraft will be developed for disaster management, mining operations, thermal mapping of fires, reef and flood monitoring, land use observation, and urban planning. Griffith is also working with Gilmour Space on a new lightweight composite rocket fuel tank designed to be up to 2 meters in diameter, which will be trialled on flights in a bid to reduce weight, increase reliability, and achieve overall launch cost savings. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The US Food and Drug Administration has rejected the British idea of delaying a second dose of the COVID-19 vaccine so that they can spread the limited supply available out further. Several American states considered following the United Kingdom's decision to delay the second dose of both the Pfizer-BioNTech and Oxford AstraZeneca vaccines by up to 12 weeks in order to give more people protection from at least one dose because of limited supplies. And the UK is not alone. Denmark is also looking at spacing out the jabs by up to 6 weeks, while Germany is considering pushing back the second shot beyond 21 days. However, the Food and Drug Administration warns that both the Pfizer and Moderna trial data was being misinterpreted, and it would be wrong to draw any conclusions about depth or duration of protection from just a single dose. It follows a similar warning by Pfizer themselves, who pointed out that the clinical trial data showing 95% effectiveness was based on a 2-dose regime separated by 21 days. The deadly SARS-CoV-2 virus, which is now suspected of escaping from the Chinese government-run Wuhan virology lab a year ago, has killed almost 2 million people worldwide and infected some 90 million others. Scientists warn that 5 waterways near Brisbane, which were once home to Australia's unique platypus, appear to no longer have any of the monotreme mammals living there. A report in the journal Australian Mammalogy claims researchers looking for platypus DNA in 54 waterways around Brisbane failed to detect any evidence of the animals in a number of streams. Areas of concern include the mid to upper Bremer River west of Brisbane, Scrubby and Slacks Creeks south of Brisbane, and the Noggara and Kedron Brook north of Brisbane. Platypus had previously been recorded in these waterways, but the researchers failed to detect any of their DNA at multiple sample sites despite repeated efforts. A new study shows that crops grown near the Chernobyl atomic power station are still contaminated due to the 1986 nuclear accident. Scientists analysed a range of grains, including wheat, rye, oats and barley, and found concentrations of radioactive isotopes strontium-90 and cesium-137 well above Ukraine's official safe limits in almost half of all samples. The study by the University of Exeter and the Ukrainian Institute of Agricultural Radiology also examined wood samples, finding 3/4 contained strontium-90 concentrations above Ukrainian safe limits. Scientists analysed 116 grain samples collected between 2011 and 2019 from both just outside the exclusion zone and from a location 50 kilometres south of the power plant. The Chernobyl nuclear disaster occurred on April 26, 1986, when the number 4 reactor at the Chernobyl nuclear power plant exploded during a safety test. The explosion was eventually blamed on a design flaw in the RBMK-type nuclear reactor, which was commonly used throughout the Soviet Union and is still commonplace in much of Russia and former Eastern Bloc countries today. A new study claims having some avocado every day is good for intestinal health. A report in the journal Nutrition found avocados are rich in dietary fibre and monounsaturated fatty acids, nutrients that improve the digestive physiology of the intestinal microbiota as well as its composition and metabolic functions. Researchers had previously found that avocados reduce blood cholesterol concentrations. The study involved 163 overweight or obese people between 25 and 45 who were otherwise healthy. Participants consumed between 140 and 175 grams of fresh avocado daily as part of a meal or an isocaloric control meal once per day for 12 weeks. Researchers found that people who ate avocado every day had a greater abundance of gut microbes that break down fiber and produce metabolites that support gut health. They also had greater microbial diversity. Avocados are rich in fat. However, the authors found that while the avocado group consumed slightly more calories than the control group, slightly more fat was excreted due to lower overall food absorption. The end of the line for the Flash player, and we ask whether or not you're suffering from nomophobia. To explain all, we're joined by Alex Zaharov-Reutt from ity.com.
Yeah, well, Adobe Flash, about 10 to 15 years ago, Adobe Flash ruled supreme. Everyone used it. It was the way that you ran interactive content online. It was even the software that YouTube used to play all the videos that made YouTube famous. But the problem was that whilst it was a standard for Windows and Macs, Apple and Steve Jobs refused to support it for the iPhone and the iPad.
That made
Android
life so difficult.
And that's right. But the problem with Flash was that it was designed for desktop processors and desktop amounts of memory. It wasn't designed for the relatively puny, at the time, mobile processors that were used in phones. And you even had Adobe Flash being used as a selling point for early Android phones. But the experience was, it just wasn't smooth. It wasn't as good as a desktop. It was very taxing on the phone, used up a lot of battery and caused a lot of heat. And there were just issues. And eventually Adobe abandoned it. And what Apple did was push the internet further towards HTML5 and open web standards that can work on any browser. And, Adobe Flash was buggy. It had problems, and so in 2017, Adobe announced that by the end of 2020, it would make Flash end of life. And so we've now had that happen. 31st of December was that date. And the 12th of January 2021 is when Flash Player, if it's still on your PC or Mac, it actually won't run Flash content at all. So Flash is a security risk. It's buggy. Adobe recommends you uninstall it, and it's the end of an era.
What's nomophobia?
Well, this is an Australian first study that measures nomophobia, which is no mobile phone phobia. I guess in America, it would be no cell phobia, which would be no cellular phone phobia. But it's measuring the consequences of this, and it shows that 99.2% of Australian users have some fear of being without their phone. Now, 13.2% of the population have severe nomophobia. This leads to an increased risk of dependence and dangerous use, which includes using the phone in the car whilst you're driving, which of course is illegal in Australia and in most parts of the world. So this is done by research from Behaviour Works Australia, which is part of the Monash Sustainable Development Institute, part of Monash University. They surveyed nearly 3,000 Australians on their psychological attachment to their phone and usage habits, and they found that nearly half of all participants, 43.3%, they spent upwards of 3 hours a day on their phone. I'm sure the stats would be similar in the US. And the more that people use their phone, the higher the level of nomophobia and the greater their risk of problematic, dependent, prohibited, or dangerous usage. Now, young people aged 18 to 25 have the highest level, which is no big surprise. Males were almost twice as likely to engage in dangerous use than females. Again, driving, trying to check messages or engage in video calls or watching video content in their cars whilst they're driving, which of course is illegal. In Australia, 84% of the population has mobile phone internet access, and there are more mobile phone subscriptions than people, 109.6 per 100 inhabitants. So the study found users with nomophobia were 11.7 times more likely to have a problematic phone dependency and 10.3 times more likely to use their phone in a prohibited space like a library, classroom, or a cinema. They're also 14 times more likely to engage in dangerous use such as while driving, cycling, or walking. So look, people themselves, they're probably listening to their podcasts on their phone. They know that they reach for their phone at different times. People have rules not to use their phone at dinner time or at other times. You should try and be present with the people you're with rather than being sort of half present, checking notifications and things. But this is the world we live in now. We live in a world where we have our phones and the world's repository of unlimited information in a little tiny gadget that fits in our pocket. Soon, Apple making developments, soon to be in our field of vision permanently through augmented reality glasses. So do you suffer from nomophobia? If you do, it's an addiction, and I guess you have to try and wean yourself off it a little bit.
I'm sort of halfway there, I guess. I don't need to be on my phone all the time, but I do need to know it's there in my pocket. If I've left it in the car or I've left it somewhere, then the anxiety rises.
Yeah. Well, I do remember that even in the days when Nokia phones ruled supreme, that people, if they didn't have their phones when they left, sometimes they would turn back and go and get it. And
oh, yeah.
That was back then. But today, look, today at least you can have your watch share the same number as your iPhone, for example, and there are certain Android watches that can do the same. It's not the same. And you do sort of, you want your phone, it's become a habit for us all. So nomophobia is real, and it's, potentially one of the blessings and the curses of the 21st century.
That's Alex Zaharov-Reutt from ity.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.